and welcome to another episode of 3-Minute Videos with Nathaniel. Today we'll now solve question 1B of MAT Oxford 2013. We have the graph of y equals to sine x, so let us draw that here. The graph of sine x looks like this. So on. So now it is reflected at x equals to pi and reflected at y equals to 2. Now, the question asks for the equation of this final graph. First, let's look at the first transformation, reflected at x equals to pi. Obviously, this will not take a lot of effort for you to realize that x equals to pi. X is 2 pi, don't get confused. But this line is actually x equals to pi. And now, if we reflect it, I'm using a green marker for first transformation, this will become this graph. Look familiar? It's the graph of negative sine x. So let's write here. Now this graph, again, is now reflected at the line y equals to 2. So let me put down the marker. Sorry, I dyed my hand. And anyway, this answer for reflected at y equals to 2, we put y equals to 2 here because it's above the maximum value. And this is 0, so that means the reflected distance above should obviously be 4. Again, we perform a transformation of this transformed graph, making this. Interesting, right? Look at it. It's the exact same figure as sine x, which it is. So now, the equation for this graph is 4 plus sine x, which is what we need. Bingo! We have our y equals to sine x graph. We do some reflection and we actually learn where the sine x gets into the axes. Don't get confused though. Remember I said this is 2 pi and this is pi, but it gets worse because sine x is periodic, meaning that the function repeats values at some point in time. For example, if I make this periodic function y equals to x mod 1, which means get the fractional part of x. So I'm just making a contrived example here, and this is periodic with period 1. What does that mean? So let's say we pick 0.6, then y will be 0.6. But if 1.6, then the answer is 0.6. 2.6, 0.6. It works. Let's try another set of values. 0.3, 0.3, 1.3, 0.3, 2.3, 0.3. This is periodic with length 1, meaning that it repeats after an x value of 1. Yeah, I hope this nice digression of periodic functions has got you a little insight into why sine x actually behaves like sine x and not any other graph like y equals to x squared, y equals to square root of x, y equals to 1 over x, or y equals to 576 times x plus 333 over 90 to the power of 5,000. Of course I was a little contrived here, but yeah, sine x is periodic and not like any other polynomial function, like these four, or any other function like e to the power of x, ln x, or 2x times 2 to the power of x. There! Trigonometric functions behave the way they are because they are periodic. And I hope this digression will give you a wonderful insight into how I solved MAT question B 2013. Goodbye!